Hello everyone, let us learn today about the number system. What is number system in computer? Number system is actually a technique to represent the different kind of numbers within the computer system architecture. Whatever value we enter from the keyboard or whatever we are saving into the computer's memory, it is going in the form of a number system. Alright, so that is why we are going to learn about the number system. Computer actually supports the, or you can say the architecture of computer supports the four kind of number system. First one is the decimal number system, second is the binary, third is the octal number system, and the fourth one is the hexadecimal number system. Now let's see the number system architecture. As we have already seen, there are four type of number system. So the first one, decimal number system, the base is 10, which means that it supports the number starting from 0 till 9. Then there is a binary number system which supports only two numbers, 0 and 1, and the base is 2. Now the octal number system, the base is 8 and it supports the number from 0 to 7. And in hexadecimal number system, the base is 16. The number included can be represented from 0 to 9, and preceding the number from the 9, from 10 to 15, it will be represented from the alphabet A to F. Now let us see the conversion, that how we can convert decimal to binary and binary to decimal. Let us begin converting the number from decimal to binary. You can see on the screen I have written decimal to binary. Going to convert this number 36, and I want to find out that what is the binary number of this number 36. So as we know that the base of binary number is 2 and the base of decimal number is 10. So we are going to divide this 36 by 2. So I am writing here 36, and we will divide it till the time it is divisible and the remainder becomes 0. So I am writing here 2 1s are 2 and 2 8s are 16. So the remainder will become 0 here. Then 2 9s are 18, remainder is again 0. 2 4s are 8, remainder is 1. 2 2s are 4, remainder is 0. 2 1s are 2, remainder is again 0. So students, you can see that now it is not divisible. So we got the binary number of the number 36, which is 1000100. We will count it from down to the up this direction, right? So I'm going to write the output here now. So let me write, the answer will be 100100. So this is the answer of this number 36. So it means that 36 is equal to 100 and 100. This is the binary value of the number 36, right? So now let us convert binary to decimal. To understand it in a better way, I am going to convert the same number, this which is given here, the same number from binary to decimal. So as we know that the base is 2. So for converting it binary to decimal, there is a formula. So students, you can see that on the screen I have written that digit into base to the power position, which is the formula to convert binary to decimal. So I am going to convert the same number which I got here. Let's see that we got the answer 36 or not. So for converting the number from binary to decimal, we need to write the number and we have to define its position, which is given here, that you have to define the position. So the position will start from 0 and it will go till the length of the number. So let's write here like this: 1 0 0 1 0 0. This is our binary number which we want to change. Now I'm going to define the position, and the position I will define starting from 0 1 2 3 4 and then 5. So this is the length of the number. It will start from 0 and will go in a back direction from right to left, and it has gone till 5. So now we will put all these details onto the formula. So the what is the digit? Here you can see the digit. You can start from here as well and you can start from here as well. So let us begin. Now I have written here the digit. Digit is 1 into base is 2. We know that the base of binary is 2 and the position is 5. So I have written 1 into 2 to the power 5 plus digit is 0, base is again 2 and the position is 4. Digit is 0, base is again 2, position is 3. Digit is 1, base is 2, position is 2. Now again digit is 0, base is 2, position is 1. Digit is 0, base is 2 and the position is 0. Now let us solve this. So 1 into 2 to the power 5 will be 32. So 1 into 32 will be 32 only, plus. Now here it will be 16. However, it is multiplication by 0. So the output will be 0 only. So let's write like this. It will again be 0. Here 2 2s are 4 and then into 1. So it will be 4. And here you can see it is 0 and then again 0. So students, one thing I want to confirm, that whenever there is a number whose power is 0, it is equal to 1. Anyhow, this is 2 to the power 0 is equal to 1, but 1 into 0 will be 0 again. So you can see here that after adding we are getting the number here 36. So this is our required, or you can say this is the answer which we got, and it is similar to this one. So it means our this conversion and this conversion both are correct. So this is how you can check the answer as well, and you can convert from decimal to binary and binary to decimal. I hope you have understood the conversion now, students. So practice few of the numbers and try to solve it from binary to decimal and decimal to binary both. And if there will be any problem, you can ask me. I'll discuss the next topic in the next video. Till then, stay safe, stay home. Thank you so much.